Okay, with this video, I want to show you how to use another aspect of the Bode plotter. So I'm going to share my screen, get Circuit Maker, and put myself up in the corner here, although I think I end up there anyway. So here I've opened up Circuit Maker, and this is also experiment number 3. And I'm going to go over to File because I've already made this one. So let's open it up. And this is looking at the resonant frequency circuit. So I'm going to open this guy up. In the experiment, I ask you to build it just to get your Circuit Maker building skills a little bit more fine-tuned. But I've taken and I've opened up the bandpass amplifier here on the left-hand side of the screen. So in the other video, we talked about -3 dB points and roll-off rate. Here we want to talk about bandwidth, and we'll see how we can measure bandwidth, and then from bandwidth we get the circuit Q. So let's take a look and run this. So if I run this, what happens? I already set up the the simulation is already set up here and so forth. So what we see is we see an oscilloscope, and of course it's the not so dark banner up here. So the one that's active is this guy down here, the AC analysis Bode plot. So I'm going to blow this guy up the full screen here. And what I'm going to do is drag the A cursor across here and see where the highest point is. I'm going to blow it up again. And oops, here we go. I'm going to take and just go over it. Oops, by it. And you can actually see here, that's a calculation point, that's a calculation point, another one. So what happens is the calculation points are stringed together with straight lines. But of course, when it's not blown up, it turns out that it looks like a curve. So what this tells me here, if I go over and click anywhere on the screen, 162.1 kHz would be what this is. So I'll go back to the counterclockwise arrow, and the resonant frequency of this bandpass filter is 162.1 kilohertz. Now, how do I determine the bandwidth? And the bandwidth by definition is the F low to F high, where F low and F high are both 3 dB lower than the maximum output. So I'm going to move myself up here on my screen. I'm going to go grab the C cursor and bring it down so it's right on top of this, someplace there. And then the D cursor here, and I'm going to try to bring that up so it's 3. So I'm going to blow this up. And now I can move the C cursor up using my up arrow keys to where it should exactly be. And it's right there. And the D, I'm going to try to bring that up. And went a little bit too far. Let's see if we can get right on it. -2, 9. That's, I guess, this is as close as I'm going to get, I think. That's as close as I'm going to get. Now, how we get the F low is, again, it's 3, the output over here, that's F low, is down 3 dB from its maximum output. So I'm going to move A over here. And of course, notice that I can't quite get it right on it. I'll use the arrow key if I can to take and move it around. And boy, I just really can't get it. About as close as I get is there, I think. If I hit the arrow key again and I jump up further. Now, the only way I could, make this work is go back into the simulation and basically take and set the number of points higher. But I'm going to be satisfied with just this. The B cursor I'm going to grab for F high. And let's see how close we can get that. F high bounces around here. Oh my goodness. So F high. And it looks like about as close as I can get that is here. So I'm below on one and above on the other. Maybe I'll compensate. So what I see is that A to B, which is the difference between F high and F low, which is the bandwidth of this filter, is 8.921 K or K hertz. So almost 9 kilohertz is the bandwidth. I go back here, you see that it'd be very difficult to get, A and B on there to make any measurements. Now, in the experiment, we ask you to change a resistor, I think R sub S, from its value of 6.3 ohms. Let's take a look at the, if I can drag this down here. Yes, 6.3 ohms over here to a different value. Let me do it real fast just to show you. Here goes the kitty's tail. Let's go and change this value here to say 25 ohms. So let's see what happens. Move that to 25. Okay. Now I'll run this circuit, and what you see is over here the bandpass filter is not as sharp as it was before, and I would have to adjust C and D to get new F high and F low points. So now, C would have to come up to here. D would be somewhere around, let's see, -3 is actually way down here. Yeah, just about somewhere in there. And it turns out that, A and B would be way over here and way over there, which now are a bandwidth of about 76 kilohertz. Q is the resonant frequency, which remember was 162 kilohertz divided by the bandwidth. So this would have a very low Q compared to the sharper one we had with the 6.3. And I also ask you to make RS 2.5 ohms, and you'll discover that's even sharper still, and that bandwidth is narrow. So hopefully this has been helpful. How you measure bandwidth of a circuit. Again, you go to F low. Here's the resonant frequency. F low is the -3 dB point below it. F high is the -3 dB point above it. By -3 dB point, we mean where does the output fall down to -3 dB of what the highest value is. Okay, so that's it for this little video.